Hello viewers, welcome to my channel KK Concepts of Electrical Engineering. Now prove that conduction current equals to displacement current in a capacitor. Proof for this. Now consider a parallel plate capacitor C which is connected to a supply or AC voltage that V equals to V naught cos omega t. Now a capacitor gets charged and discharged alternatively and the current flows through the circuit. This current is known as a conduction current and denoted by the letter I, which is given by C dV by dt. Now substitute the value of V, then C d V naught cos omega t divided by dt, then C. Now cos omega t when you differentiate, sin omega t minus, and omega t when you differentiate, omega, then V naught. Where V naught is a constant and peak value. For parallel plate capacitor, capacitance C is given by epsilon is by d, where S is the area of each plate, d is the distance between the plates. Now substituting this C value, the conduction current I is given by minus of epsilon S divided by d V naught omega sine omega t. Let this be question number 1. As the capacitor charges and discharges, there is a transfer of energy from one plate to another, but since the intervening medium is dielectric, there is no conduction current through the capacitor. A displacement current ID may be visualized through the capacitor. D is given by epsilon E, where E is the electric field intensity, and E is given by negative gradient of voltage or V by D volts per meter. Then D equals to epsilon negative V by D. Now from which substitute the value of V, you are going to get minus E. V is V naught cos omega t divided by D. Now the displacement current ID is equals to dd divided by dt, that is equals to minus epsilon, this is epsilon not E, d of minus epsilon V naught cos omega t divided by d. Now when you solve this, you are going to get minus epsilon V naught omega sin omega t divided by d is per unit area. Now ID is equals to minus epsilon S divided by area V naught omega sin omega t. Let this be equation number 2. Now by observing equation 1 and 2, the RHS sides are equal, so we can write that conduction current I equals to displacement current ID, hence proved in case of a capacitor. Let us solve a problem. A capacitor has a capacitance of 1.5 picofarads. Find the displacement current at t equals to 0 if voltage 5 sin 100 pi t is applied. So given C equals to 1.5 picofarad and the V voltage, this is 5 sin 100 pi t. Now we need to find out ID at t equals to 0. Since ID equals to I, that is conduction current, let us find out the conduction current. Then I is given by C dV by dt. dV by dt equals to d 5 sin 100 pi t divided by dt. Now for this, 5 into 100 cos 100 pi cos 100 pi t. Therefore I equals to C, that is 1.5 into 10 to the power of minus 12 multiplied by 500 pi cos 100 pi t. When you calculate this will be 2356.2 into 10 to the power of minus 12 cos 100 pi t. Now we need to find out this ID at t equals to 0. Now when this I at d, now it became, since I equals to ID, 2356.2 to 10 to the power of minus 12 cos t is 0, so 0, cos 0 equal to 1, so 2356.2 picoamps, and current ID equals to 2.356 nanoamps. If you have any suggestions and queries, please mention in the comments. If you like this video, please like, share and subscribe. Thank you for watching the video. Please stay tuned for more videos.